Why is traveling to Mars such an engineering challenge? Imagine trying to send a spacecraft to a planet that is millions of miles away, with no guarantee of a quick return. That's what makes traveling to Mars such a tough puzzle for engineers. The distance alone is staggering. Depending on where Earth and Mars are in their orbits, the trip can be between 55 million and over 400 million kilometers. This means spacecraft need to be built to last at least 6 to 9 months in space just to reach Mars. During that time, astronauts need air to breathe, water to drink, food to eat, and systems to recycle waste. All of this has to work perfectly, with no chance for resupply. Then there's the issue of space radiation. Outside Earth's magnetic shield and atmosphere, radiation levels jump significantly. This radiation can harm astronauts' health, so spacecraft and habitats must have shielding to keep everyone safe. Protecting humans from these radiation dangers is a big part of the engineering challenge. Landing on Mars adds another layer of difficulty. The planet's atmosphere is extremely thin, less than 1% the density of Earth's. On Earth, thick air helps slow down a spacecraft during descent. On Mars, that's not the case. The usual parachutes and airbags used for robotic landings won't work for the much heavier human-rated spacecraft, which can weigh between 50 and 100 metric tons. Engineers are working on new ideas like inflatable aerodynamic decelerators to help slow the craft down. But safely landing a large crewed vehicle on Mars is still one of the biggest hurdles. The surface environment is also very harsh. Temperatures can drop to hundreds of degrees below freezing. Dust storms can last 4 weeks and block sunlight, making solar power difficult. The soil contains reactive chemicals that could damage equipment or habitats. Astronauts need special training to live and work in these conditions, including how to handle limited resources and maintain their habitats. Communication is another challenge. Signals between Earth and Mars can take up to 20 minutes to travel one way. That means astronauts can't rely on instant support from mission control. They must be trained to operate complex systems and solve problems on their own. Finally, engineers are developing ways to produce supplies on Mars itself. Extracting water ice for drinking, oxygen, and rocket fuel can cut down on the amount of supplies that need to be launched from Earth. This process, called in-situ resource utilization, is vital for making long-term missions feasible. All these factors, long travel times, difficult landings, harsh environments, autonomous operations, and resource production, make traveling to Mars one of the most complex engineering tasks in human spaceflight. It's a challenge that pushes the limits of current technology and requires innovative solutions at every step.